Hello everyone. Today I'm going to explain the third problem of Leetcode Biweekly contest 155, which is count cells in overlapping horizontal and vertical substrings. So what is the problem? We are given a grid of size in %, and a string pattern. Okay. So a horizontal substring means that we can start from any index of the grid and we can go to the right side. Okay. And if we reach the end of the row, then we can move to the starting of the next row. Okay. So let's say we have started from A, C, C, and we are end of the row. Then we can go to the next row and start from B. So A, C, C, D, like this will continue. But if we are at the end of the last row, then we can't really move to the first row. Okay, so that is the horizontal substring. We can take any start and any end. Okay, similarly, a vertical substring will be like this. Okay, let's say we are starting from, let's say, this A, so we can go A, C, A, and if the column is end, then we will go to the starting of the next column. Okay, A, B, like that. Okay, but we can't really go from the end of the last column to the start column. Okay, first column. Okay, so and we have to find the number of cells which are part of both horizontal as a vertical substring and horizontal substring, which is same as pattern. Okay, so a horizontal substring and vertical substring is same as pattern. So for the first example, you can see that this is the grid and the pattern is ABACA. So you can see that one vertical substring is this and one horizontal substring is this. Okay, this C is part of both horizontal substring and vertical substring. Only C is the this cell is part of both of them. So the answer will be 1. Okay, if we take the second case, then I have not examined the second case, but here, as per the example, these two cells and these two cells are both part of the horizontal and vertical substring. So the answer will be 4. Okay, answer will be 4. Okay, so what is the possible solution to this? Okay, the possible solution to this will be to iterate over each and every substring, each and every horizontal and vertical substring, and try to find try to increment some counter. So let me discuss the brute force solution. Okay, so let's say we have some grade. Okay, we have some grade. So let's say 3 cross 3 grade. So whatever we can do, we can take all the horizontal substring, and all the vertical substring, and whenever we find the starting, let's say start from I comma j and ends at k comma l. Okay, some horizontal substring. So we know the exact path from I to j. Let's say from this to this, we know the exact path. This will start from this, and again this will forward this. Okay, so this is the path. This is the path. So we can in the path we can mark each and every cell by 1. We can increment the value of each and every cell by 1. So let's call that horizontal ordering. So let's say horizontal ordering of a cell plus plus. We are doing horizontal ordering of a cell plus plus. Okay, and similarly, whenever we are doing some kind of vertical ordering, let's say we have found the vertical order. Let me write it here. Okay, let me draw another thing. Okay, so let's say we find a vertical substring like this. This will go till this and this, right? This is the, let's say, vertical substring. Then we can we know the path, right? This will go from this and this. So whichever nodes are part of this vertical substring, we can do vertical of cell plus plus. Okay, we can do vertical of cell plus plus. Okay, so that means that we are doing horizontal cell plus plus and vertical cell plus plus. This is what we are doing, right? Then at the end, what we'll check? We'll check that if the cell is horizontal of cell is greater than 0, and similarly the vertical of cell is greater than 0, then we can say so what is the condition? This is that, say, let me write that h of c is greater than 0. H of c is greater than 0, and similarly vertical of cell is greater than 0, then we can say that this cell is part of both horizontal and vertical substring. Then we can increment our answer. So what is the, this is the brute force solution, and this will work. But what is the time complexity of the solution? The time complexity is that we are trying to find each for each ij we are trying to find kl. Okay, so the overall time complexity will be the total grid size, which is nm. Okay, overall time complexity will be nm square. Okay, order of n square n square. Let's look at the constants now. Okay, so here you can see that m and n are 1000 and m into n is 10 to the power 5. So the solution of order of nm square will not help us because it will be around 10 to the power 10. So we have to think something better. We have to modify our algorithm in such a way that this solution works in order of nm or order of nm log nm. Okay, so whenever we find some problem related to pattern searching, There are three ways. One of them is uh, string hashing. I have not used string hashing in this uh, Rabin-Karp algorithm. Rabin-Karp algorithm string hashing. Another thing will be KMP. So I have used KMP. Uh, so this is the first string hashing, and the second is KMP. So I have used KMP in this problem. Okay, I have used KMP in this problem. KMP pattern matching. KMP pattern matching. What does it do? It finds all the starting indexes. Let's say we are given some text. Okay, we are given some text and some pattern. Okay, text and pattern. So this KMP, what will it do? It will give us all the starting indexes present in text, such that text of I to I plus length is the pattern length. So text of I to I plus length is our pattern. Okay, so it will give us all the values of this I. Okay, so I am not going to explain KMP, but I have an article for KMP. So this is the exact same thing I have done in my code. This the compute LPS will find the LPS array for the given pattern, and this search function will give us a vector of int starting indices. Okay, starting indices. This is the starting indices of this eyes. Okay, I hope you get it. That's what it do. And now I will you can read this article, or you can search about KMP in YouTube. You can find some suitable videos also, video tutorials. So I am skipping this part, not going to explain KMP. Also I have some videos on KMP. I will attach the link also. You can check the description section to get the link. Okay, so let me jump to the code. I will explain how I have used this part, and in this problem I have solved the KMP using KMP in the problem. So these are the two important functions. One is get index. This is the important function actually. Get is not get is actually calling get index and finding uh, the specific value for the specific index. Okay, so for KMP operates on a string, right? So in KMP, text is a string, right? Text is a string, but in our case there is no text. We have a grid, right? We have a grid of n cross m. Okay, we have a grid of n cross m. Okay, let's say, let me write our one of our grid. Okay, let me take another color, you will understand better. Let's say we have something like A B C and D E F and sorry D E F and let's say G H I. Okay, so if we take horizontal substring, then our text will become like this. Okay, if we take horizontal wrapping, so our string will be like this: A B C D E F and G H I. Okay, G H I. And similarly, if we take the vertical ordering, then our string will become let me write it in different color. The string will become ADG B E H and CFI. Okay, CF, this is CFI. Okay, now so in the code you can see that what KMP algorithm does is that it finds text of I. Okay, so let's say we are doing we are at a specific index I could be from 0 to n to m, right? 0 less than equals to I less than n into m, nm. Okay, so 0 less than equals to I less than n to m. So we are at a particular index I. Okay, now we will also have some parameter, which is it horizontal or is it vertical. Okay, is it horizontal or is it vertical. Okay, so if it is horizontal, then for the given I, what is the row and column number. Okay, for the given I, for the given index, let's say we are given some index from 0 to n minus 0 to nm, then this index, if we pass that it is horizontal or vertical, it will give us the row and column number. Okay, it will give us the row and column number of the okay row and column number in the given grid. Okay, so that's what our grid index get index is doing. Okay, so get index is doing what? Get index is giving us the row and column number for the given index. Okay, so if it is a horizontal string, if it is a horizontal substring, then this is normal ordering. Okay, so you might know that like it will be numbered from 0 1 2 3 4 5 like that. Okay, so if we want to find the row number, we'll divide it. Let's say our index will, let's say this is our I, So if we try to find the row number, we'll divide it by column size, I by m. And if we try to find the column number, we'll divide it by modulo it by m. So this will be our row and this will be our column if we go horizontal substring. Now similarly for vertical substring, the row number will be nothing but this will be get reversed, and this m will change to n, and this operators will also get reversed. So now row r will be I modulo n, and our column will be I by n. Okay, I hope you get it. What for different vertical and horizontal substring, how we are getting the row and column numbers. Okay, so these two functions I have explained. Now the compute LPS function is exactly same as like in GFG, but the KMP functions I have modified it. How I have modified it? The first thing is that instead of doing text of I am getting the character from this function, get of index, grid, and horizontal. Okay, so instead of doing text I am doing get of I, grid, and horizontal. Okay, and I am comparing with pattern J. And another case, so in this case you can see that we are pushing the starting index. So instead of doing that, I am taking one difference array. So difference array means that let's say this is another concept. So let's say in some array, okay, in some array, okay, we want to do a range update. We want to do a range update from L to R. Okay, we will try to do a range update from L to R. So what can we do? We can increment the value of the L index by +1 and decrement the value of R by -1. Okay, let's say another index is there. So now if we take a prefix sum, then the value from L to R, it will get +1 contribution, but before L it will get 0 contribution, and before after R it will also get 0 contribution. So only L to R this +1 will be the contribution. So I know that from I minus j to I minus 1, this is a pattern match, right? From I minus j to I minus 1, this is a pattern match. So that's why I am incrementing the value of this left is I minus j by +1, and I am decrementing the value of r, which is I, by -1. Okay, and at the end I am doing one prefix sum. Okay, and I am returning the difference array. So difference array will give us that if the some index, some cell has the value greater than 0, that means this is part of a horizontal or vertical substring based on the boolean value we are passing. Okay, so for horizontal we are passing the horizontal flag as true, and for vertical we are passing the horizontal flag as false. So we are getting the horizontal vector and the vertical vector. So horizontal and vertical vector, if the ith cell is greater than 0 in horizontal, that means that is I index is set as a horizontal substring, and if it is set in the vertical array or vector, it means that we found a vertical substring involving this cell. Okay, now you might think that after that I also thought that that's why I got a wrong answer. So I also thought that so no, I don't did not have a wrong answer here, but I have a wrong answer in the example test case. But what I thought is that I can check that if the both horizontal of a cell I and vertical of a cell I, if both are greater than 0, then we can say that this I is possible, then we will do answer plus plus. But I forgot one case there, that the I is not same. I is not same in horizontal and vertical ordering. Okay, so that's why we have to get help of our get index function again. So I am taking one map which will be take one row and column pair as a key, and count as a frequency as a value. Okay, so I am taking get index of I comma true. So true will give us the horizontal row and column for the given index, and we are doing plus equals to horizontal I greater than 0. Okay, so we are checking that after at the end, if entry dot second equals to 2, that means it came. That's why we are doing horizontal I greater than 0. So a cell can be part of multiple horizontal substring and multiple vertical substring, so we can't really do horizontal I and vertical I, so it will give us wrong answer. Okay, so that's why we are doing horizontal I greater than 0 and vertical I greater than 0. Now empty dot second is equals to 2, that means this is part of both horizontal and vertical substring. Then in that case we are doing answer plus plus. Okay, and then we are returning the answer. So overall time complexity is order of n, order of n into m, order of n into m. I will attach the I'll attach the KMP article in the description box. Also the link of my video where I have explained KMP in detail in the description box. You can check that out. Also, I'll attach the code link in the description box. If you have any doubt in any part of the video explanation or code, you can always ask in the comment section. I'll try to reply each and every comment. If you find this video helpful, please like the video, subscribe to the channel, and also share among your peers. Thank you.